Welcome at the Hydrogen Fuel Cells Europe here at Hannovermesse 2022. My name is Muriel Burkas and I will host the next interview. If you wonder why we repeat ourselves over and over again, all this is also live streamed. So for our people watching this from far, far away, we're gonna introduce ourselves every time before we start a talk. Please have a seat, get some refreshments and enjoy the next talk. We will talk about the missing link solving the hydrogen storage challenge. Please welcome on stage from Rix Industries, Dean Alvarado. Good to have you here, Dean.
Thank you. It's nice to be here.
So, what is Rix Industries exactly doing? Why are you here?
Reason why we're here, Rix Industries, we've been in business for over 140 years, primarily in the industrial gas compression business. But we're always looking for new ventures, new horizons, and we saw that the burgeoning hydrogen economy for providing clean energy is maybe the next frontier. So we're here to promote what we feel is the solution to what we call the hydrogen storage challenge, which is our M2H2 hydrogen generator. And we could talk a little bit more about that as we go along.
Yeah, so what's the solution? Can you dig deeper? What are you exactly offering to solve the challenge?
So before we talk about the solution, let's talk about the problem. So, hydrogen fuel cells, that's a great solution to providing clean energy. But the issue right now is what I've been running into with talking to different people in the hydrogen community is there is a lack of infrastructure for supply and distribution. And it's through our hydrogen generator that provides on-site or on-board and on-demand hydrogen, fuel cell grade hydrogen. We believe that is the solution to this infrastructure problem.
Okay, so that's the solution. Why? What's the advantage? What is the offering exactly?
Right. So, the problem is getting the hydrogen to the point of use, whether it be on marine vessel, whether it be on rail, anywhere. Right now, the two ways that hydrogen is provided for the fuel cells is through high pressure hydrogen or through transport of liquid hydrogen. Those two solutions right now, there are some technical difficulties with it. I mean, to transport high pressure hydrogen at 350 or 700 bar requires these very huge, very expensive vessels that take up a lot of space. The other way is through liquid hydrogen, which, as I'm sure all of you may know, is a very energy-intensive process to liquefy hydrogen and keep it in its liquid form till you get it to the point of use. Our solution is we use methanol. Methanol is a widely, pretty much readily available, is readily available throughout the world. It's used in a lot of chemical processes, and the infrastructure is already there. So what we do is we use methanol as a hydrogen carrier. And why is it such a good carrier? Is because one, it has a very high energy density, almost 20 times more than gaseous hydrogen. Two is it's a liquid. It's basically a liquid at atmospheric pressure. So you don't have to worry about keeping it in these high pressure tanks. You don't have to worry about cooling it down to cryogenic temperatures. You could just transport it in any sort of traditional fuel tank that's used as of now. So we use this methanol as a hydrogen carrier. You can easily transport it to where it's going to be used, and then our generator will use methanol steam reforming to convert that into pure hydrogen, 99.9% hydrogen.
So the methanol is a good or safe option to bring hydrogen from A to B.
Yes, I would say it's a relatively safer and less costly method of, again, carrying your hydrogen to where it is required.
And why methanol and not maybe another gas?
I mean, again, steam reforming is not exclusive to methanol. There are other companies that do methane reforming. That's possible. But again, the issue is if wherever your application is, if it has access to the natural gas grid, then sure, methane reforming makes sense. But if you're talking about marine vessels where they do not have access to the gas grid, if you're talking about some remote areas, say in the Australian outback, where again, no easy access to natural gas, then methanol, again, much easier to transport, much easier to get, and you can bring that over to where it's needed.
Okay, you already touched the topic a bit, but maybe can you elaborate what are the applications for your solutions? Where is it used?
Sure. So what we're really going after now is the mobile applications. Let me just back up a little bit. So methanol reforming, I'll admit, it's not a cutting-edge technology. I mean, this has been around for many years, but Rick's partnering with a company, E1 in Oregon. They're the ones who took the concept of methanol reforming and parsed it down from a refinery scale down to a more compact self-contained unit. So because it's a self-contained unit, relatively small, we believe it has good application for mobile industry, so being the marine industry. And then also we're looking at rail applications as well. I mean, one potential I see, we already have here in Germany the Alstom's Island hydrogen train. And I think that may be a potential application for us. From what I understand, currently they use a huge hydrogen tank to provide hydrogen for the fuel cells at, again, high pressure. Maybe I'm just a little, I'm a little worrisome, but the fact of riding in a train car next to a huge hydrogen 700 bar vessel is a little unnerving to me. With our reformer, again, it's using methanol as a feedstock, again, relatively safe. And since we're producing hydrogen on demand, we're basically producing it as required as it's being used. We don't have to pump it up to the high pressures to get that extra capacity. We're only providing hydrogen at maybe 1 or 2 bar versus 700 bar. So you never have gobs of hydrogen at high pressure at any time. So again, I think just general safety and general optics and feelings for passengers, I think that's where we can play at.
Okay, this makes sense to feel also safer, because that's also one of the issues that people maybe have. I would like to open up at this point to the audience if there are any questions at the moment. Good. If not, I will continue. You still can have a seat if you're standing, have some refreshments, and join the conversation. You already mentioned it a bit, military and also marines and railway. What kind of clients do you have at the moment? Who are your clients? Are these two, others as well?
Yeah, so fairly recently we have received 2 orders. Again, I can't really go into details of who the customers are. Recently happened, but again, it's for marine industry. Two of them for, again, use on marine vessels. We are close to closing an order for a land-based application. So again, we're mostly going for mobile, but this same unit can be used for a land-based application for providing hydrogen fuel cell, hydrogen for hydrogen fuel cell. So that is another application where we're coming to close to closing.
So what kind of projects are at the moment ongoing at Rix Industries?
I mean, well, pretty much those 2. And again, we're still continuing to explore what other applications are possible. Again, this is a very new technology. We just signed on with this company about 3 years ago. And again, I mean, just the whole hydrogen economy is anew. We're all sort of together, trying to find our way. So.
Okay, there is a question from the audience or from the next speaker.
Yeah, thank you. So if you can't tell the customer, but the power range, maybe you can tell. And what kind of technology are you using for the reformer? Is this a fixed bed, or how does that look like? You can tell a little bit?
Yes, sure. So the technology, again, it's basically we have a small reformer reactor. So we take a methanol feedstock, and within our unit, it becomes vaporized and then goes into our methanol reactor with a catalytic bed. Of course, it basically goes to its own steam reforming, and you produce a syngas, which is basically a mixture of hydrogen, CO, methane. And to get the fuel cell grade purity, within our same unit, we have a membrane-based purifier, which then will recover and purify the hydrogen to your 3/9 purity, and then the leftover we send back to the reactor, to the burner for the reactor to continue the reaction. I'm sorry, what was the other question you had? I'm sorry.
Power range.
So we have two models, but I'll just talk about our larger model. We call it the M2H2 1800. So basically, it creates about 1,800 standard liters per minute, or 10 kilos an hour of hydrogen. So that's enough hydrogen to supply, say, a 200 kilowatt fuel cell. What's nice is these are very scalable. So if you need more power, say if you need, one megawatt of power, then you could scale these up. You could put 4 or 5 of these in parallel to produce enough hydrogen. A very scalable technology.
Thank you for the question. Thank you for answering. Looking at the time, maybe one last question. You said we're all in this together. It's a young technology.
Yeah.
So where is it going from your point of view in the industry, but also for RIX Industries? Where do you see you're heading the next years?
I mean, again, just being here, RIX has been at the Hannovermesse quite a number of years. This is my first time attending. But it's very exciting. I walked the floor yesterday and saw all the different types of technologies based on clean hydrogen energy. So a very exciting time, just seeing what's available out there. But as far as where we're going as a group, as far as clean energy, I think what I'm seeing is we have quite a lot of different solutions. I'm not saying that our solution is the end all, the cure all, but I think just everything that's out there. I mean, we have we have wind, we have solar, we have electrification, batteries. And then as far as hydrogen fuel cells, we have stored hydrogen, okay? And then we have on-site generation, our technology, and electrolyzers. I mean, 5 possible solutions we have. I think the thing we want to try to avoid is think of this as 5 different solutions. I think with all of this together, if we can all come together, I think we could really be a force for change, for improving the world for us and for generations to come. So I think, again, it's not going to be one, it's going to be all of us moving together, complementing where we are. Again, in certain situations, our application makes sense. In other applications, for example, electrolyzers, if where they need to produce hydrogen is right next to a hydroelectric dam where they have energy available, that makes more sense. If I'm talking about a homestead out in the outback of Australia, where they're currently using diesel gensets for power and have no connection to the grid, I think that's where we would apply. So again, it's not going to be one, it's going to be all of us together.
Okay, I think that's a beautiful last sentence, and the cake is big enough for everybody.
Yeah.
So thank you so much for being here today, Dean Alvarado. Big round of applause for you.
Thank you.